So this is our project, and for this one, we used a spring mechanism, and since our spring we had two springs, and it would be hard to determine the spring constant for both of them. We set it up so that we would always launch the marble at a constant velocity, so the initial would be the same. And how we did that, Robert would explain.
We have a trigger system here that walks it back at the same distance every time, so you get the same amount of pullback force every time. Launches through the tube using the spring that's located here. Comes out here, and we use the photo gate to get the initial velocity, and then we used a board marked at the same place every time to be sure we got a constant angle after every shoot, and that was determined using a protractor.
Alright, and since we're always going to be having a constant velocity, so we therefore use a simple projectile equation, y equals y naught plus initial velocity of y times t plus 1/2 gt squared. And how we did this was that we first calculated the height from the floor to where the marble would be launched out, so about around here. And since the bucket also has a height, our y naught was our bucket, which would be placed around where that marker is over there. And our acceleration is always going to be the gravity. And we calculated Vy by taking the initial velocity of the marble there and use the angle to to calculate the y component of that velocity. So it came, and we calculated the angle over there, and it turned out to be about 13.6 degrees. And our initial velocity was 6.47 meters per second. So we set up the equation so that when our marble goes into the bucket, which will be placed eventually, our equation will be 0 equals 6.47 sine 13.6 t minus 4.9 t squared plus 0.76. And that would give us a time that we need, that would give us a time that would take the marble from there to when it hits where that marker is. And once we have the time, we just find the x component of this velocity, which is cosine theta times the initial velocity, which is 6.7, times the time it takes. And that would give us the distance. And the distance turned out to be 3.65 meters, but from the distance here to there is about 3.5 meters. And the reason we did it like that is because since this is a real life experiment, air resistance and friction is always taken into account. So even though theoretically it should be a little further, those forces are going to subtract our distance, so we place the marker a little less than the theoretical distance, and it should hit when our assistant places the center of the bucket on where the marker is.
Here she comes.
Right there?
Yeah.
A little.
Why did they get a bigger bucket?
We chose that bucket. We had a choice.
Oh.
Good.
A little bit
A little further out.
There we go. Oops.
Oh, that.
I'm not trying to do this, Robert.
A little too far.
Give him a big hand. Tape's rolling.
Okay, so this is trial 2 of our projectile experiment,
And the only thing we changed is that I'm not going to use my finger to lift the trigger because that clearly didn't work last time. And that ended up moving this and affecting where the marble got shot. So instead I'm going to use my fist because that apparently has more strength. So, yeah.
Oh!
All right. All right.
And marble was